As you can see, he's thinking of theorems, probably trying to prove the theorems in his sleep. What a genius.
Now, related rates are all about change in time, as opposed to change in space, which would be ddx or ddy. As a first example, let's look at the equation of the unit circle. Now, if we find the rate of change with respect to x of this equation, then by what you might know as implicit differentiation, you would have 2x plus 2y times dy dx by the chain rule for this step right here is equal to 0. If you were to differentiate with respect to y, which you probably haven't done, but you would get by the chain rule again, 2x dx dy, and this step now by the chain rule, plus 2y is equal to 0. If you were to differentiate with respect to time, so here we assume both x of t and y of t, or x is a function of time and y is a function of time, then you have a chain rule for both terms. So it would be 2x dx dt plus 2y dy dt is equal to 0. And this 0 right here is d dt of 1. And here it was d dx of 1. And here it was d dx of 1. I'm sorry, this is d dy of 1. So when you differentiate a constant with respect to any variable, it's 0. And then each of these derivatives has an associated chain rule depending on which variable you're differentiating with respect to. So here we have a chain rule for this term because we're differentiating with respect to y. Here we have a chain rule for this term because we're differentiating with respect to x. Here we have a chain rule for both terms because we're differentiating each function with respect to t. So you'll recall, for example, the reason we don't have a chain rule when we differentiate x cubed, for example, with respect to x, is that the derivative would be 3x squared times dx dx. This would be the associated chain rule, and because let's consider a circle problem. So we have a radius and we have an area, and we want to use the equation area is equal to pi r squared, the area of a circle. Now, sometimes we'll be asked a question like this. Find the rate of change of area when the area is equal to 100 pi if dr dt is equal to 2 feet per second. So I suppose the units would also be given to you here. The area is 100 pi feet squared. So in this kind of a problem, you typically want to start the same way, true for all of these related rate problems, differentiate with respect to time. So you would have dA dt is equal to pi times 2r dr dt. And so notice we have our chain rule step here, and on the left hand side we just basically applied d dt to a and got dA dt. Now when it says find the rate of change of area, okay, find this value is dA dt, right? So this one is dA dt. That's what we mean by the rate of change of area in time. So we're looking for this quantity, and in order to find it, we have to find r and dr dt. Now one of these quantities is given to us, this value right here. So right away we can plug this value in, and we'll get pi times 2r times dr dt, which is 2. So let's just make this into a big parenthesis and put a 2 like that. Okay, so this is our 2 right here. So how do we find r? That's the question. In order to find r, we have to use the equation itself because we're given a. So it's like a puzzle where you have to find the information that you need from the information that you have. So we have 100 pi, the area, is equal to pi r squared from the equation. And we want to find r at the moment that this thing is happening. So the pi's cancel. You get 100 is equal to r squared. And so you would have plus and minus 10 is equal to r. However, we just choose the positive radius because radius is a positive quantity. So this one would then be pi times 2 times 10 times 2, 40. So this is 40 pi, and then you have to get the units right. So this is an area, so that's going to be feet squared divided by time, which in this problem is seconds. So feet squared per seconds would be the rate of change of area in time. So for our next example, let's say this one was of easy difficulty. Now we'll look at one more medium difficulty. Suppose you have two bicyclists and they're riding away from each other in orthogonal directions. So usually they'll say like one's going south and one's going east. So for example, we could say like the one bicyclist is going east at a rate of 18 miles per hour, so east, and the other one is going south at a rate of 15 miles per hour. So this could be a lot of different objects that are moving. You have like two cars that are driving away from each other in these directions. This is a right angle, that's why they usually say south and east. This is going to allow us to use Pythagorean theorem. Maybe you have two people that are walking away from each other. You have two bicyclists, like this problem, that are riding away from each other, something like that. Two ships, okay? So there's many different cases, but they're all the same problem. And usually they'll say like, how fast, like at what rate, is the distance between them changing after some amount of time, like after 20 minutes. Okay, usually they'll choose a number here that divides these numbers easily. So here's the idea. In this problem, you basically have a right triangle. Okay, now you're given the rate is 18 miles per hour here and 15 miles per hour here, going this way and this way. Notice this one naturally lends itself to the x-axis and this one naturally to the y-axis. And usually if we have a triangle, if this is going to be like x squared, y squared, z squared, then what we'll want is the distance z and x and y. And so we can use x squared plus y squared equals z squared from the Pythagorean theorem. So all of these problems involving triangles very often involve this relationship. X squared plus y squared equals z squared, and you have to choose the coordinate system for the problem. So they're not going to give you this is the x direction and this is the y direction. You have to come up with that assignment. So after 20 minutes, we have, if you go 18 miles per hour for 1 hour, you'll go 18 miles. If you go 18 miles per hour for 20 minutes, you'll go 1/3 that distance. And so here, x would be equal to 6, and y would be equal to 1/3 of 15 miles would be 5 miles. Okay, so this would be 6 miles, and this would be 5 miles. And so now we could find z here using that relationship. So you have basically 6 squared plus 5 squared is equal to z squared. So 36 plus 25, 61 is equal to z squared. So the square root of 61 is equal to z. Don't be alarmed that this is not a nice square root. It just is the number that it is. Okay. So now we're going to come back to this equation right here, and in order to find how fast the distance between them is changing, so if you try and identify what you're looking for, how fast the distance between them is changing, that quantity would be dz dt. Okay, so this is the quantity that we want. And we know dx dt and dy dt, and we know x, y, and z. So if we differentiate this equation into 2x dx dt plus 2y dy dt equals 2z dz dt, look what we know. We know everybody. We know this, and this, and this, and this, and this, and this is what we want. Right? How do we know that? Well, we have these numbers that we found, and this one, that's x, y, and z, respectively. And then we have this rate, and this rate, that's this rate, and this rate. So everything is known in the problem. Basically, it's just going to be 2 times x, which is 6, times dx dt, which is 18, plus 2 times y, which is 5, times dy dt, which is 15, it's supposed to be a time, so just make it into a big dot, is equal to 2 times the square root of 61 dz dt. So we want to solve for this quantity right here. So we basically are going to have dz dt is all this mess. So let's say 2 times 6 is 12, so 12 times 18 plus 10 times 15 divided by 2 times the square root of 61. And this one is a rate of change of distance in time. The units are miles, so this will be in miles per unit time of this problem, which is hours. So miles per hour. So here's a harder problem that involves similar triangles. It's one of the classic problems in related rates. In this problem, it says water is draining from a conical reservoir at a rate of 50 meters cubed per minute. How fast is the water level falling when the water is 2 meters deep? The tank is 5 meters tall with a radius of 45 meters. So first thing we want to do is think about the information that's given to us in the problem and draw a sketch. So this is a conical tank, so this is what they mean. It's like a cone, and it's upside down. That's information given in the problem. So you could also have a cone that was right side up, like this, and some problems are stated this way, but this problem is like this, and water is draining out at a rate of 50 meters cubed per minute. So we think about the information that's given. The draining rate, 50 meters cubed per minute, is a rate of change of volume in time. So this quantity right here, we want to think about as dV dt. Now, the operant equation for a cone of this type is the volume is equal to 1/3 pi r squared h. And very typically, this is something that you're going to need to remember. Rarely is it given on a test. And if you want to take the derivative with respect to t, you usually have to remember that there is a product rule here. It depends on the information given to you in the problem. And we'll look at 2 techniques for solving this kind of a problem, but if you need to use the product rule, then you would have to say dv dt is equal to pi over 3, and then first the derivative of this term, so 2r dr dt, times h plus r squared, then the derivative of this term is just dh dt. So sometimes you need to take the derivative like this by the product rule. Let's examine 2 methods for solving this problem. So here's method 1, and I think the simplest method. Now, we want to find how fast the water level is falling, which is dH dt. So we can use a similar triangle technique to do this. If we have the water level has fallen, okay, to a certain amount, then there'll be a similar triangle relationship between this piece here and this piece here. So if the height at some later time is this h and the radius is r, then the relationship will be 45 over 5. The overall radius over the overall height must be equal to the radius here divided by the height here. So by similar triangles, the ratio of this to this is the same as this to this, since these 2 triangles are similar. Now this technique is very often used in, like, you have a situation like this where there's a pole and there's a light source, and you know information about this triangle and you want to find information about this triangle, or there's like a fence and something's being thrown over it, and so you want to exploit this similar triangles relationship. It's one of the, I would say, the key features of many of these related rates problems. So this is 45 and 5, and the 5 goes like this, and this is r and h. And so what it says is that, like, 45 over r is 5 over h, or 45 over 5 is r over h, etc. And you can get all of the relationships that hold by getting any one of them and modifying it. So for example, 5h is equal to 5r, or 9h is equal to r. And so we can use this in the volume equation to simplify 1/3 pi r squared h with this relationship right here. Because recall, what we want is dH dt. So if we can get rid of r in this equation, that's a benefit. Here we have pi over 3, and r is 9h, so 9h squared times h. This is now pi over 3 times 81h cubed. So what happened there? 9 squared h squared times h is 81h cubed, and that's equal to v. So now what we can do is we can take the derivative with respect to time. So we get dv dt is equal to pi over 3 times 81 times 3h squared dh dt. Okay, this is the quantity that we want, and presumably we have this h. So we go back to the information. When the water is 2 meters deep, this is our h. So here we have dv dt, the rate of change in volume, is 50 meters cubed per minute, is equal to pi over 3 times 81 times 3h squared times dh dt. All of this is just a constant, so we divide it to this side, and we should get our final answer. 50, notice the 3 cancel here, divided by pi times 81 times 4 is equal to dh dt. Typically we need to put in the correct units, so we have the rate of change of height in time, so we have to use meters per minute. Or you can put the units here like this, meters per minute, something like that. The second method, we're going to use this equation right here. So if we have dv dt is equal to pi over 3 times 2r dr dt times h plus r squared times dh dt, and we want dh dt. We need to find a relationship between dr dt and dh dt, and we do that using similar triangles as before. So we used the same relationship right here to get 45 over 5 is equal to r over h, to get 45h is equal to 5r. So if we start from there, 45h is equal to 5r, this tells us that 45 dh dt is equal to 5 dr dt, or probably would have been simpler to start from here, divide by 5, and you get 9 dh dt is equal to dr dt. So now we can replace dr dt here with dh dt. One more piece of the puzzle remains, however, using this method. So we have to find actually what r is when h is 2, and to do that we're going to use similar triangles again. So we know 9h is equal to r, so this tells us when h is equal to 2 that r is equal to 18. Okay, so this h here corresponds to this h here. So now we can take this value and we can substitute it for r here. We can take this relationship here and we can replace dr dt with that, and we know h and we know r. So actually this r here, this r right here is going to get used here and here. But everything is now known and we can solve the problem by product rule. So we'll have 50 is dv dt, which is going to be equal to pi over 3 times 2r times dr dt, which is 9 dh dt. So times 9 dh dt times h, and h is actually equal to 2, so we can replace that right away. Let's just put a 2 in here, make it a 2 somehow. Oh, terrible. Let's put a 2 like that, times 2, plus r squared, so 18 squared, times dh dt. So this one is going to be pi over 3. We can simplify this to be 18 squared times dh dt times 2 plus 18 squared dh dt. Now if I have two 18 squared dh dt's plus 18 squared dh dt, I have 3 18 squared dh dt's. So this is pi over 3 times 18 squared times dh dt, and I have 3 of them, so times 3. This 3 will cancel this 3, and you get pi times 18 squared dh dt. It's dh dt. So now if we divide to this side, we should get the same answer as before. 50 divided by pi times 18 squared is equal to dh dt. And if we compare this with method 1, we see the answers, they're different. Well, are they different? Well, this one has units, so we should probably add that, meters per minute. But are these numbers the same? You plug it into a calculator, you'll see that they're the same. I'll give you another method. The question is 81 times 4 equal to 18 squared? So we can use a little bit of knowledge of algebra and put this into factors. 81 is 9 times 9, and 4 is 2 times 2, and this is equal to 18 squared, which is 18 times 18, and this is 9 times 2, and this is 9 times 2.